start looking at circles. And I love the circle chapter because just like special right triangles that we did, not just special right triangles, but the triangles that we did last chapter, the right triangles, a lot of times you guys don't have a lot of information about circles that you know. You might know some of the vocab, but you don't know the ins and outs of circles, so it's kind of fun to teach you when it's brand new. So the vocab you're filling out on your own, but the yellow blanks we're going to talk about, just some things that you might not have been able to find in the reading. Just make sure you also draw pictures to go with the vocab. All right, so you can notice that there are a lot of new vocab words with circles. So the first thing is this radius. When you think of a radius, one radius of a circle versus all the radii is the plural. If I draw a picture of a bunch of radii, what you might notice is just like the spokes of a wheel, those radii are all congruent to each other. So it's going to be that all radii of a circle are congruent. So I want to kind of clue you into a type of picture that you might see, and you might want to sketch this just along the side. A lot of times what will happen is the book will give you a triangle made up of two radii as two sides. That will be an isosceles triangle. So keep in mind that they may not mark those radii congruent, but automatically as soon as these two radii are sides of an isosceles triangle, they're going to be congruent, and then that would make these base angles have to match. So just be on the lookout for that. They like to get cute with isosceles triangles in this chapter in that way. All right, then you should have filled in a chord. And just to review, a chord is just a segment that has endpoints on the circle. But a chord could be special in the sense that a chord could actually pass through the center of the circle. And if it does that, it's called a diameter. So a diameter is like a special type of chord that actually goes through the center. It's the only time that it does that. And by the way, that is the longest chord of the circle. So if it ever asked you for the longest chord, the diameter would be the longest one in the whole circle. All right, concentric circles I want to go over. So let's say that you were in a pond that was like still water, and you dropped a rock in the middle of that pond. You would probably start seeing ripples, and they wouldn't be exact circles, but you get the idea. Or you can think of like the Target logo, because the Target logo is a target. And when you guys have a target that has circles in there that get bigger as they go out, those are called concentric circles. They all have the same center, but the radius gets longer as you go out of those concentric circles. So that's a term I wanted to show you. You may have seen them before, but not known they were called concentric. All right, a couple more. Pi. Pi is a ratio we're going to be using this chapter, and so you probably have heard of pi, and you probably think of it as 3.14. So what pi is, it's the ratio of the circumference of a circle divided by the diameter. So you might not know this, but if you take any circumference of a circle, like the distance around, and you divide it by its diameter, you're always going to get a number close to 3.14. Every circle in the world has that ratio, which is so cool because no matter if it's a huge like swimming pool or a tiny little dime, if you take the circumference divided by the diameter, you'll get something close to 3.14. And then finally, the last thing for the vocab I want to talk about is exact answers. We're going to start using this term this chapter. We've been leaving things in radical form, which is an exact answer. So when I say exact answer, you will not approximate. You will not have decimals in there. You won't have anything that causes you to type something into the calculator as a decimal. So you will leave things in pi form or radical form. So you might have an answer like 23 pi. That would be an exact answer. You might have an answer like 5 radical 2 pi. That's an exact answer. That means everybody in the room has that exact same answer, and nobody is typing in the decimal or rounding. So keep in mind when it says exact answer, you do not multiply pi out, and you do not multiply your radicals out. Okay, so now we're going to start doing these examples. So if you have not filled in the vocabulary, you will definitely want to do that first just to get an idea about some of these terms. So down at the bottom is just a basic question. You could probably do this without my help, but we're going to run through it. So this is a circle, and we're going to run through some different vocab with the circle. So when we name a circle's name comes from that center point. So what you do is you draw a little circle picture with a dot in the middle, and you just name it by the capital letter that's in the center. So my name of my circle is Circle X. It's really easy to do, center letter. Okay, radii, that's the plural for radius. So when you have more than one radius, it's a radii, and we're going to name all of them. So if you filled in your vocab, then you know that a radius is a segment that starts at the center and goes to the edge of the circle. Now, these are all segments, like you filled in the vocab. So we're going to name them. So segment XU is a radius, comma, segment XT is a radius. And you're going to put that little segment bar on top to note for the notation that it's a segment. You're going to keep going. Segment XV is a segment, and segment XZ. So when you get done, you should have 4 segments. They all have X in them because that's the center point, and they all should have the little segment bar above them. Keep in mind, you could switch the order of these letters. You could say UX, TX, VX, and ZX. It doesn't matter what order you name a segment in. Okay, chords. If you did your definition at the top, a chord is a segment whose endpoints are on the circle, and it could be a diameter. Okay, so let's go look for the chords. So one chord in this circle is chord RS. Notice R and S both sit on the circle. It doesn't have to go through the center. It just has to have endpoints on the circle. So we say segment RS is a chord. Now, if we want another chord, we look around, and I don't see any other chord besides this chord, which is the longest chord, and its endpoints are on the circle. So it's a diameter, but that's still a chord. So we're going to say segment ZT. And again, you could switch the order of the letters. Now, a diameter is a special type of chord. That's the one we just named. So that's another name for that chord. It's just a special name because it happens to go through the center. So this is segment ZT, or you could say segment TZ. All right, so those are some basic vocabulary words. So flip over to the next page. So we are going to do example 2 just because I want to show you the relationship between a radius and a diameter. These should feel really easy to you. So if I say that TU is 14 feet, and I go to the picture and I put 14 feet in the picture, and then I ask for the radius, there is a relationship between the diameter and the radius. The radius is half of the diameter, which you should have learned when you were little. So if I just take 14 and divide it by 2, I'll get the radius is 7 feet. That is super easy. I just want to remind you of that relationship. The radius is half the diameter. All right, now let's do this one. This time it says that QT is 11. So that means all radii of a circle will be 11 because they all match. And then they want the QU, which is another radius. So we're going to say QU is also 11 meters because all radii of a circle are congruent. So again, those should seem really easy to you. All right, so for these you're going to skip. So just X out this large portion here. We're not covering these this year due to time. We're going to go down to the next example, which is example 4. So you do not need to complete the ones that we just skipped. All right, so now what's going to happen is we're going to take our circle stuff and we're going to add on something called circumference. So you guys would have filled out your vocab, and when you filled out your vocab, you might have reviewed here that circumference is the distance around a circle, not the inside of the circle, it's the outside perimeter of a circle. All right, so this says a circular amusement park has a diameter of 44 feet. So I'm going to go ahead, this is a ride, has a diameter of 44 feet. I'm going to go ahead and label this 44 feet. And it says what is the radius and what is the circumference. Okay, well, if the diameter is 44, then the radius is going to be 22 feet. How did I get that? I just take the diameter and divide it by 2, like we did on the top question. Now what I'm going to do is I'm going to find the circumference. Okay, so on the front vocab, you would have filled out 2 formulas for circumference. Circumference can be 2 pi r, which is the formula for the distance around a circle, or you can get rid of the 2 and the r and just make it pi d. So these are both your formulas. You should know those from middle school. These will both work in the circumference when you're finding them. This is what you want to use if you're using the radius, and this you can use if you're doing the diameter. Okay, so if I want the circumference of the ride, I'm going to take, I can either use my diameter or my radius, so I'll just do my diameter. This will be pi times 44. Now, if they ask you for an exact answer, you're going to leave it 44 pi feet. That is called an exact answer. So you'll have to look. If they say, hey, I want you to round to the nearest tenth, then go ahead and take your calculator and you're going to use your pi key. So if you have a scientific calculator, it should have a pi key on it. So you would just type in 44 pi, hit enter, and it will multiply 44 by that 3.14159, and then you would round it to like 138.2. That is an approximate answer. So 138.2 feet would be an approximate. So keep in mind, it will sometimes ask you for the exact answer, and sometimes it'll ask you for the approximate. If it's the approximate, you'll multiply it out. If it's exact, you leave it in. And here's how I think of it. Everyone in the room should have the exact same answer because nobody rounded if it asks for exact. All right, so we are going to now look at, let me just make sure that I covered what I wanted to on that. Yep. All right, we're going to go to part B. So part B says the circumference of a circular swimming pool is 18 pi. All right, so this time they're giving me the 18 pi as the perimeter. And they're asking me to find the diameter and the radius. Well, these are my two formulas that I can use for circumference. So since they want the diameter first, I'm going to go ahead and use the pi d formula, and then I'll just divide by 2 to get the radius. Okay, so n for the circumference is going to go 18 pi. And then over here, I have a pi, and then my d I'm trying to find. So it's like I'm going to work backwards. I'm solving the equation for d. So I'm going to divide by pi. And when I divide by pi, since there's already a pi on top, I will be able to cancel those, just like radicals would. If there wasn't a pi on top, I would actually have to take 18 divided by pi, but I can just cancel those. So my diameter is 18 feet, and then it also wants the radius, so we're going to divide 18 by 2, and we're going to get 9 feet. So those are your two answers working backwards. And again, this should seem really easy to you because you've done this in middle school and maybe even late elementary. You would have done questions like this. All right, so let's move to the last two examples, which are example 6 and 7. They're going to get a little bit harder, but not terrible. So for example 6, it says the right triangle shown is inscribed. Okay, so your vocabulary word for inscribed means that the points of the triangle will be sitting on the circle and the triangle is inside the circle. So we use the word inscribed to stand for if the triangle's inside and all the points are on it, it's inscribed. The circle is called circumscribed, but the triangle is called inscribed. So keep in mind the thing on the inside is called inscribed, the thing on the outside is called circumscribed. All right, it says find the exact. Okay, so go ahead and circle exact. We don't want a decimal for this. We want it to be non-type. We don't type in the calculator. We want to leave it as a pi and no decimal. We're going to find the exact circumference of the circle. Okay, so I'm going to go ahead and write the formula. You can either use 2 pi r or pi d. We'll just decide which one we want to use in a second. Okay, so come over here. We're going to try to figure out what the radius is or what the diameter is so that we can plug it into the formula. Now, because we haven't learned this one theorem, I want you to add a little right angle in the corner. I would give you that right angle for this problem. There's a theorem later on that you'll learn, but this is a right angle. So think about what you did in chapter 8 and how you could find the hypotenuse and use that to get your diameter or your radius. So you guys might notice that this is not special. And if something's not special and you can't use trig or geometric mean, then we're going to do Pythagorean theorem. Okay, so over to the side, we're going to set up Pythagorean theorem. 12 squared plus 8 squared equals c squared for the hypotenuse. So this is going to be 144 plus 64 is going to be 208. Okay, so now we know that c squared is 208. We're going to square root, and we are not going to use a decimal because it says exact. So we're going to simplify 208. So what we do is we start looking for perfect squares that go into 208. And as you go down the list, you're going to hit a 16 times a 13. And so the 16, when you bring that out, will become 4 radical 13. And so the c, that's not circumference, that is the diameter. This is 4 radical 13. And we got that by doing Pythagorean theorem and simplifying. Okay, so now we're going to take this, which I'm going to actually make this a d now for diameter. And we can either go into the diameter formula, or I could take half and use 2 radical 13 and put it into this formula. Well, I'm just going to use pi d, because why not? I have my diameter. So I'm going to do 4 radical 13 times pi. And the pi will usually go in the back like a variable. That is my exact answer. You do not want to plug it in. You do not want a decimal. You want to leave pi in there, and you also want to leave your radical in there. So all you do is you take your diameter and you just put pi right in the back of that, like it's a variable. That's the circumference. And then, let's see, did it give us units? Yeah, it did centimeters, so we'll add on centimeters because it's just perimeter. It's not area, so don't put squared on there. All right, last example. This time it says a square with sides 10 feet long is circumscribed. Okay, so if the square is circumscribed, that square has to be on the outside, and the circle is what's inscribed. Okay, this is going to be weird because it's going to be opposite from what you think it should look like. So put your square on the outside, and then you're going to inscribe your circle so that your circle will hit each side of that square. So the square is circumscribed and the circle is inscribed. And it says the sides of the square are all 10 feet long. So I'll just put a 10 on all the sides of the square. All right, find the exact circumference. Exact, meaning do not approximate. So what we need to do is we need to write our formulas, either 2 pi r or pi d we can use. And we go over to the picture, and we're going to draw in the diameter, which is our longest chord of a circle. So using your square, what you can do is say, okay, well, if my square has a side of 10 feet, then this distance across here would also have to be 10 feet. Now, just for fun, I'm going to make the radius 5 feet, which is half of the 10, so that I can use the 2 pi r formula just to show you how that works. So you could put 10 right in there and be done, but I'm going to go ahead and put in 2 pi 5, which is the same thing I would get as if I put in a 10 there. So notice that if I use 2 pi r, I just double the 5, and I still get 10 pi. And I do not want to type that in because it said exact, and so I don't want to estimate. I want the exact answer. And then because it's in feet, we're going to put feet as units since it's the distance around the circle for the circumference.